Hey there. Ever stop to think about all the changes happening all around us all the time? From a simple ice cube melting to an old nail getting rusty. Well, in this explainer, we're going to break down the science behind all that. And by the end, you'll have a totally new way of looking at the world. Okay, so just take a look at all this. We've got milk going bad, water boiling away, wood on fire, and metal rusting. I mean, they're all examples of change, for sure, but are they really the same thing? What's the real difference between boiling water and burning wood? Let's figure it out. So here's our game plan. We're going to start by building a simple way to sort changes. Then we'll look at things like time and whether we can hit the undo button. After that, we'll dive into the two most important scientific types. That's physical and chemical change, and we'll wrap it all up with a real-world example.
All right, first things first. To start sorting all this out, let's ask a super simple question. Who or what is making the change happen?
First up, you've got natural changes. These are the ones that just happen, right? An apple ripening on a tree, milk going sour in the fridge. They happen all by themselves, no help from us.
And then, of course, there are the changes we cause. Sharpening a pencil, baking a loaf of bread. Anytime a person is the reason for the change, well, that's a man-made change. We're the ones making it happen. Okay, another way we can slice this is by thinking, is this change good for us or not so much? Cooking food, super useful. It makes things taste way better and easier to eat. But spoiled milk, yeah, that's definitely a harmful change, especially if you were about to pour it on your cereal.
All right, so we've talked about what causes a change. Now let's look at some other key details, like how fast it happens and, more importantly, can we reverse it?
I mean, some changes are crazy fast, right? A balloon bursting, bam, it's over in a split second. But then you have something like a piece of fruit ripening that takes its sweet time, unfolding over days or even weeks. And this brings us to a really, really important question. Can the change be undone? Can we get back what we started with? The answer to this is a huge clue about what's really going on. So think about it like this. You melt an ice cube. No big deal, right? You can just pop that water back in the freezer and get your ice cube back. But what about a ripe, sweet mango? Can you turn that back into a hard green one? No way. That's a one-way street.
And that right there is the perfect example of reversible versus irreversible changes. Reversible changes, like melting ice or wax, can go back and forth. But irreversible ones, like fruit ripening or wood burning, well, once they happen, that's it. There's no going back.
Okay, just a couple more labels to add to our toolkit before we get to the big stuff. Some changes are periodic. They happen on a schedule, like clockwork. Think about the sunrise every single morning. Others are non-periodic. They're random and unpredictable, like a meteor streaking across the night sky.
Okay, so we've got a pretty good system now, right? We can sort changes by their cause, how useful they are, their speed, and whether we can undo them. But now we're going to get to the real heart of the matter. Because at the end of the day, the most powerful way to look at all this is to ask one simple question. Does the stuff itself actually become something new? The answer divides every change in the universe into two main groups. And this is it. The two big ones in science, physical change and chemical change. Seriously, if you get this, you get a whole lot about how the world really works on a deep molecular level. Okay, so a physical change, think of it like a change of costume. It might look different, but it's the same stuff underneath. Ice, water, steam, it's all just H2O, right? It just changed its outfit from solid to liquid to gas. Nothing new was actually made.
But a chemical change? Whoa, that's a total transformation. When you burn wood, you don't just get hot wood. The wood is gone. It's been turned into totally new things. Ash, smoke, carbon dioxide. A brand new substance has been formed.
This chart lays it all out perfectly. See? With a physical change, no new stuff is formed, the composition stays the same, and you can often reverse it. Think of dissolving salt in water. You can always get that salt back. But with a chemical change, you get a totally new substance. The composition is transformed, and it's usually irreversible, like rust. You can't just unrust a nail, can you?
All right, let's take everything we've just learned and put it to the test with something we've all seen, rust, or as scientists call it, corrosion. You know that reddish-brown flaky stuff you see on an old bike or a garden gate? That's rust. So let's use our new toolkit. Is it slow or fast? Definitely slow. Harmful or useful? Harmful for sure. Reversible? Nope. And the big one? Physical or chemical? It's gotta be chemical, because the iron has literally turned into a new substance, iron oxide.
So, what's actually going on here? What's causing this chemical change? Well, it's surprisingly simple. It's just the iron atoms reacting with oxygen from the air. And you know what really speeds it up? Water. Air and water are like the dynamic duo for creating rust.
But check this out. This is where knowing the science is like a superpower. Because we know rust is a chemical change, we can figure out how to stop it. One cool way is called galvanization. It sounds complicated, but all we're doing is coating the iron with a thin layer of zinc. The zinc basically acts like a bodyguard. It reacts with the oxygen and water first, sacrificing itself to protect the iron underneath. How cool is that? We're fighting a chemical change with another chemical change.
So, what's the big takeaway here? It's that the world around you is constantly putting on this incredible show of physical and chemical dramas. Think about it. The toast you made this morning? That's a chemical change. The ice melting in your drink? That's a physical one. And now you have this awesome toolkit to not just see these changes, but to actually understand them. So here's a challenge for you. Just look around right now. What transformations can you spot, and how would you classify them?